ever wonder how they make sure all the apps and software we use actually, work?
It's a process, that's for sure.
Yeah.
There are a lot of moving pieces.
Right, like we just expect things to function smoothly, but a ton goes on behind the scenes to ensure that happens. So today, we're taking a deep dive into one crucial aspect of that process, black box testing.
Yeah, it's a fascinating way to approach software quality.
Absolutely. We're going to explore how this approach helps us understand software from the outside in, basically, from a user's perspective, without even needing to look at the code.
That's the beauty of it, focusing on what the user experiences rather than the technical nuts and bolts behind it.
Exactly. And we've got some excellent material here that breaks down black box testing in detail, explaining the core techniques and principles involved. Our mission today is to distill the most important and practical knowledge from these sources so you walk away with a solid understanding of how this testing magic happens.
It's all about ensuring that the software behaves as intended
Hmm.
from the point of view of the person actually using it.
Right. And to give you a roadmap for this deep dive, we're going to focus on three key black box testing techniques.
Those are the real workhorses of this approach.
Absolutely. We'll be exploring boundary value analysis, equivalence partitioning, and decision table testing. Each one offers a unique and powerful way to ensure that software functions correctly in the real world.
They each tackle the problem from a slightly different angle, which is what makes them so effective when used together.
So are you ready to jump in and see how these techniques work?
Let's do it. I'm eager to break these down and see how they apply in practical scenarios.
Okay, great. Now, before we get into the specifics of these techniques, let's start with the foundation. What exactly is black box testing?
Well, at its core, black box testing is a method of evaluating the functionality of a piece of software, an app, a website, you name it, without examining its internal structure or code.
So no peeking under the hood, so to speak.
Exactly. We're treating the software like a black box. We know what we put in, we know what we should get out, but we don't concern ourselves with the precise mechanisms happening inside.
It's like using a vending machine. You put in your money, select your snack, and expect the machine to deliver. You don't need to know the intricate workings of the machine to know whether it's functioning correctly.
That's a perfect analogy. It's all about interacting with the software, providing different inputs, and observing the outputs it generates. The focus is on ensuring that those inputs and outputs align with what the user expects and what the software is designed to do.
So from a user's perspective, it's about making sure that when you click a button or enter some data, the software responds in a way that makes sense and achieves the desired outcome.
Right. And it's crucial for identifying those annoying usability issues, like when a button is in a weird spot or the navigation is confusing, as well as actual functional errors, where the software simply doesn't do what it's supposed to do.
It can even help find potential security vulnerabilities, right? Like if a certain sequence of user actions could inadvertently expose sensitive data or allow unauthorized access.
Absolutely. If a typical user action can lead to a system malfunction or security breach, that's a major red flag that black box testing aims to catch.
And what's interesting from the material we have is that black box testing isn't limited to just one stage of software development. It's applicable across different levels of testing, from unit testing, where you're looking at individual components, to system testing, where you're examining the entire integrated system, all the way to acceptance testing, where actual end users get involved to validate if the software meets their requirements.
It's really a versatile approach that can be applied throughout the software development lifecycle.
So it's not just for developers in the early stages, it's valuable for quality assurance teams, testers, and even end users who want to make sure the software they're using is reliable and meets their needs.
It's really about a shared responsibility to ensure software quality. Now, with a clear understanding of what black box testing is and why it's so important, let's dig into some of those key techniques we mentioned.
Sounds good. Let's start with boundary value analysis, or BVA. I have to admit, the name sounds a bit technical.
It does sound a bit intimidating, but the concept behind it is surprisingly straightforward.
I'm all ears. Explain it like I'm 5.
Haha, all right. Imagine you have a dial that you can turn to set a value, like a timer. It might work perfectly fine if you set it for 10 minutes or 45 minutes, but what happens if you try to set it for the absolute minimum or maximum value allowed?
Interesting. I could see how things might get a bit wonky at those extremes.
Exactly. Software often encounters problems right at the edges of what it's designed to handle. Those edges or boundaries are where defects tend to lurk.
So instead of just testing random values within the allowed range, BVA focuses specifically on those critical boundary points.
Precisely. Let's say we have a system that's supposed to accept numerical values between 1 and 100. With BVA, we wouldn't just test a value in the middle, like 50. We'd specifically target the minimum value, which is 1, and the value just below it, which is 0. Then we'd test the value just above the minimum, which is 2.
Oh, I see. So we're deliberately probing those transition points, the edges of the valid range, to see if the software can handle those edge cases correctly.
Exactly. And we do the same thing at the upper limit. We test the maximum value of 100, the value just below it at 99, and the value just above it at 101.
By testing these specific boundary values, we greatly increase the chances of uncovering hidden issues related to how the software handles those limits.
It's a very targeted and efficient way to identify those off-by-one errors
Yeah.
that can be surprisingly common in software.
That makes perfect sense. It's like checking the fence post to make sure the whole fence is secure.
Exactly. Now, let's move on to the next technique, equivalence partitioning.
All right, equivalence partitioning. What's the core idea behind this one?
The basic principle here is about dividing all possible input data into separate groups, or partitions, where we expect the system to behave similarly for any input within a particular group.
So instead of trying to test every single possible input, which could be an overwhelming task, we group similar inputs together and just test one representative from each group.
Precisely. The assumption is that if one input from a partition works correctly or incorrectly, then all other inputs within that partition will likely behave the same way.
Okay, so it's a way to streamline the testing process and make it more manageable without sacrificing coverage.
Exactly. Let's go back to our example of a system that accepts numbers between 1 and 100. With equivalence partitioning, we'd identify the valid partition, which is the range of numbers from 1 to 100. We might choose to test the number 50 as a representative of this entire valid range.
Because if 50 works, it's a good indication that other valid numbers within that range, like 25 or 75, will also work.
Right. But we also need to consider the invalid partitions. In this case, those would be numbers below 1 and numbers above 100.
So we might test 0 as a representative of the below 1 partition and 101 as a representative of the above 100 partition.
Exactly. And with just those three test cases, 0, 50, and 101, we've effectively addressed the entire spectrum of potential input.
It's a very efficient way to test the software's behavior with both valid and invalid data.
Precisely. It ensures we cover all the major categories of input without getting bogged down in testing every single possible value.
All right, now on to the third technique, decision table testing. This one sounds like it comes into play when things get a bit more complex, right?
You're absolutely right. Decision table testing is particularly useful when dealing with software that involves multiple conditions and rules.
Like when there are multiple factors that influence the software's behavior, and those factors can interact in different ways.
Precisely. Imagine an e-commerce system that offers discounts based on membership status and coupon codes. There are two conditions: whether the customer is a member and whether they have a coupon.
And each of those conditions can be either true or false, leading to several different combinations.
Exactly. A decision table helps us systematically map out all those combinations and the corresponding outcomes. In this case, we have 4 possible scenarios.
Okay, let's break those down. What are the 4 scenarios?
First, the customer is a member and has a coupon, which results in a 20% discount. Second, the customer is a member but doesn't have a coupon, leading to a 10% discount. Third, the customer isn't a member but does have a coupon, giving them a 5% discount. And finally, if the customer isn't a member and doesn't have a coupon, they get no discount.
So the decision table neatly lays out all those possible combinations and the expected outcome for each one.
Exactly. It ensures that we don't accidentally overlook any specific combination of conditions during testing.
It's like a cheat sheet to make sure all the discount rules are implemented correctly.
Exactly. And as you can imagine, for more complex systems with even more conditions, decision tables become even more crucial for managing all those potential scenarios.
It's all about being systematic and thorough to ensure that the software behaves as expected under all circumstances.
Precisely. Now, stepping back a bit, we've explored these 3 powerful black box testing techniques, but let's consider the broader advantages and limitations of this approach in general.
That's a good point. What are the key benefits of black box testing?
Well, first and foremost, it's user-centric. We're interacting with the software solely through its inputs and outputs, just like a regular user would. This helps us uncover usability issues and functional defects that a user might experience.
It's all about simulating the real-world user experience.
Exactly. Second, black box testing is applicable at different levels of testing. from individual components to the entire system. This makes it highly adaptable and valuable throughout the development process.
So it's not just a one-size-fits-all approach. It can be tailored to different testing needs.
Exactly. And third, it's very effective at identifying user interface and usability issues, ensuring a smooth and intuitive experience for the end user.
So black box testing helps make software not only functional, but also user-friendly.
Precisely. However, it's important to acknowledge that black box testing does have some limitations.
What are some of the potential drawbacks?
Well, one limitation is that it might not always achieve complete coverage of the internal logic. Because we're not looking at the code, we might miss some defects that only surface under very specific internal conditions.
It's like there could be a hidden bug that only shows up if a very specific sequence of events happens inside the software.
Exactly. Another limitation is that thorough black box testing can be time-consuming, especially for complex applications.
Especially if you have to try many different combinations of inputs to cover all the possibilities.
Right, and when a bug is discovered, it can sometimes be tricky to pinpoint the exact cause without digging into the code.
So you know something is wrong, but you don't necessarily know exactly where the problem lies in the code.
Precisely. And finally, black box testing might not always catch certain logical errors or internal calculation issues if they don't lead to obvious incorrect outputs.
Like if a calculation is slightly off, but still produces a result that seems reasonable on the surface.
Exactly. So, while black box testing is essential for evaluating the user experience and overall functionality, it's not a foolproof solution on its own.
It's like having a great map, but it might not show you every single detail of the terrain.
That's a great analogy. Combining black box testing with white box testing, where testers have access to the code, provides a more comprehensive approach.
So you get the best of both worlds, the external perspective of the user and the internal view of the developer.
Exactly. It's about using the right tools and techniques for the job to ensure software quality.
So to wrap things up, what are the key takeaways you want our listeners to remember about black box testing?
The main point is that black box testing is a fundamental approach for evaluating software quality from the end user's perspective. Techniques like boundary value analysis, equivalence partitioning, and decision table testing provide powerful ways to uncover defects and ensure that software functions as expected in the real world.
It's all about putting yourself in the user's shoes and testing the software the way they would actually use it.
Exactly. And while it has its limitations, black box testing plays a vital role in creating reliable and user-friendly software that we can all depend on.
Absolutely. By understanding and applying these testing techniques, we can contribute to a world with better, more reliable, and more enjoyable software experiences. And on that note, here's a final thought for you to ponder. Given that black box testing focuses on what the software does rather than how it does it, what kinds of unexpected or unconventional user behaviors might still reveal critical issues that these techniques alone might not catch? It really makes you think about the endless possibilities of how humans interact with technology and how crucial it is to test for those unexpected scenarios. Thanks for joining us on this deep dive into black box testing.
It's been a pleasure exploring these concepts with you.